Okay, so the next question is based on equilibrium of concurrent force system, and here we are going to understand how Lamis theorem is applied. So question is, a 30 kg pipe is supported at A. So you can see here a 30 kg pipe which is supported at A by a system of 5 strings. So if you carefully observe this diagram, you can see there are 5 strings or cables. Okay, so let it be, this is 1, this is 2, this is 3, this is 4, and this is 5. So total 5 cables are there. Then they ask for what? Determine force in each string for equilibrium. So here they have mentioned equilibrium, and hence this problem comes under a type that is concurrent force system. Okay, and here we are going to solve this problem to find the tension or tensile forces in each and every cable. So the first step is to draw free body diagrams. In order to solve the problem of equilibrium, we have to draw free body diagram. In order to understand in detail, I'll first erase this and I'll enlarge this figure so that I can show you proper free body diagram. Okay, so now while drawing the FBD for the concurrent force system, we are going to understand one by one all the points of the system. Here I can say A point, then there is a B, then C, then D and E. I'll draw FBD free body diagram for each and every point here, and then we will decide with which points we can proceed further to solve the same problem. So here, if I start with the A point, so tensile force is always away from the body, it is acting away from the body. So if I consider A point, then the tension in the cable AE, while drawing FBD, it should be away from the A. It should be shown like this. So this is tension AE. Then if I consider AB cable, then tension in AB is considering point A, it is away from A. So this is tension AB. Similarly, this cable is connected to the 30 kg pipe, and if I consider cable only with respect to point A, then the tensile force or tension in the cable AB here is, now see here they have given in kg, the weight of the pipe is 30 kg, but tensile force is in Newton. Hence, we have to convert this value into Newton, and this can be done by multiplying 9.81. So this is the value of tensile force in this cable segment at point A. Now I'll proceed further and I'll consider point B. Now same, there are you can see here there are 3 cables are connected at B, so 3 tensile forces, and we have already discussed tensile forces are away from the considered point. Here point is B, so tension BD this is tension AB, it is already mentioned over here, and then tension BC. So this are what the FBD is considering point A and B. If I consider point C, then it is connected to the BC cable, but tension is like this. Tension BC, same value, but the direction is opposite considering point C. Same thing happened with the D. Tension BD will act like this if you consider point D. And then E, of course, so tension A will be like this considering point E. So here, before proceeding to solve this problem, we have to decide with which point we can proceed. Now this problem comes under equilibrium, and secondly it comes under a concurrent force system. Concurrent force system means number of forces are passing through a single point. Okay, and here this case we are taken in order to understand Lamis theorem application, and in Lamis theorem we have to consider 3 forces passing through a single point. So if I consider A, there are 3 forces acting through a single point, so of course we can consider this. Then same thing happened with the B, 3 forces, tensile forces passing through a point B, Okay, but this thing is not same for the C, D and E, because there are only or you can say there is only one force passing through this point C, D and E. So we are not going to consider point C, D, E for the further calculation. We are going to consider here only A and B. So if I draw FBDs for the point A, then the first horizontal force, that is TAE, then TAB at 60 degree with the horizontal, and then the 30 into 9.81, this comes around 294.3, and it is vertically downward. I'll show the angle over here. So this is 60 degree as given in the question. Now I'll draw FBD for the B point. So this is A, this point is A. Now same thing I'll do for the point number B. Now I'll draw FBD for the point number B. So first force horizontal, that is TBC. Then TBD is vertically making certain angle with the horizontal. This is TBD. And finally TAB. So now this angle is known to us. If I consider here like this horizontal line, so this angle becomes 60 degree, and this angle also you can calculate considering this triangle. This is 3, 4, 5. We want this angle, so this is tan inverse of 3 by 4, opposite upon adjacent. So it is 36.869. so for the calculation purpose I'll take 3 digits after the decimal places, so it is 36.869. To get the more accurate answer, keep habit of taking at least 3 digits after the decimal places. So now here I'll mention the same angles. So this is 60, so this is 36.869. Now this becomes 120, and this angle is 180 minus 36.869. (180) minus 36.869, 143.131. So this is 143.131. Similarly, here I'll find the remaining angles. So this is 120, 60, 180 minus 60. This is 90 degree, and this is also a 90 degree. These angles are important in order to solve the problem using Lamis theorem. Okay. So now we have a FBD considering point A as well as considering point B. So these are the FBDs considering point A and B. Now we will see how to apply Lamis theorem. But before that, I'll explain you the Lamis theorem in a very short. See here. If there are 3 forces, F1, then F2 and the F3, and if they are forming the concurrent force system and system is in equilibrium, and if I consider these angles, this angle is alpha, this angle is gamma, let it be, and this angle is beta. So according to Lamis theorem, considering this figure, I can write here the force F1 is divided by the sine of angle between other two forces. So if I consider F1, the other two forces are F2 and F3, and the angle between these two is alpha. So this becomes sine alpha is equal to, if I consider F2, so then this is sine angle between other two forces, that is sine beta. And similarly, and then F3 upon sine of angle between other two forces. So F3 angle between other two forces is gamma. So this is the equation, it's called as the Lamis theorem. The force is proportional to the sine of angle between other two forces. So same theorem we are going to use over here, okay? But in order to solve this, we must know at least one force, okay? And if you consider this two FBDs, so here all three forces are unknown to you. All three forces are unknown to you. But if I consider FBD of A, then here TAB and TAE are unknown, but this force is known to us and all our angles are also available. Okay, so we can start with the at point A. We can apply Lamis theorem to the point A in order to solve the problem. So here, if I want to apply the Lamis theorem, so the equation will be like this. Now I'll apply Lamis theorem over here. So first I'll start with the known force, that is 294.3 divided by sine of angle between other two forces. So it is 120, the sine of angle between other two forces. If I consider this one, other two forces are this, so 120, which is equal to TAE, okay, upon sine of angle between other two forces, that is 90 plus 60, so it is 150, which is equal to TAB upon sine of angle between other two forces. If I consider TAB, the angle between other two forces is 90 degree. So here, now equation is formed. Now we'll go for the unknowns one by one. So if I equate this two first, okay, I'll equate this two first to get the value of TAE, So now here, the equation will become TAE is equal to 294.3 into sine 150, cross multiplication, sine 150 will come here, divided by sine 120. So this is equal to 294.3 into sine 150 divided by sine of 120. So this comes around 169.914. TAE is coming out to be 169.914 and unit is Newton, tensile force, so unit is Newton. Now I'll proceed further for the TAB. Now I'll equate this equation with this one, okay, these two equations I can say. So my equation will become TAB is equal to cross multiplication 294.3 into sine 90, which is actually 1, divided by sine 120. So my answer is 294.3 into sine 90 divided by sine 120. So answer is coming out to be 339.828. Newton. The unit is Newton. Tensile force, so it is in Newton. So here now we have a values of TAE and TAB. After solving the FBD of point A. So now we'll proceed further and we'll solve the, or you can say apply the Lamis theorem at point B in order to get the remaining unknowns. Here now TAB is known to you in this FBD. So now I'll solve FBD of point B. So here TAB is known to you now. TAB is known to you and it is 339.828 Newton. So now apply Lamis theorem. If I consider TAB, which is known to me, so I'll start with that. 339.828 divided by sine of angle between other two forces. So other two forces are these two. The angle is 143.131. So 143.131, which is equal to TBC divided by sine of angle between other two forces. So this is the angle. So 60 plus 36.869 becomes 96.869. So here I'll mention 96.869, which is equal to the remaining force is TBD divided by sine of angle 120. So now if I equate this to so my equation will be TBC is equal to 339.828 into cross multiplication sine 96.869 divided by sine of 143.131. So if you solve this, you will get the value of TBC. So 339.828 into sine of 96.869 divided by sine of 143.131. So this is 562.326, sorry, 562.326 that I am getting answer over here. 562.326 Newton. Now I'll proceed further, and now I'll take the next combination. Okay, so now here I'll equate this equation, this ratio I can say, with this one. Okay, so my equation will be TBD is equal to 339.828 into cross multiplication sine 120 divided by sine 143.131. So if you solve this, sine 120 divided by sine of 143.131. So this is 490.509. Newton. Now we have solved all the unknowns, and the values are TBC is equal to 562.326 and TBD is equal to 490.509. Okay, just a minute. So this is the equation for the TBC, and this is for TBD. So now we have all the four values. So now if you go through the question again, first we draw FBD to solve the problem. Then once you define the FBDs, decide with which points you want to proceed. Once you finalize the points, draw FBD separately for the each point, and then find out the point at which you are getting at least one force known. Okay, so here we started with the A because this force, that is the weight of the pipe, is known to us. And then we solved this applying Lamis theorem. We got the TAE and TAB in this FBD. Then we use the value of TAB in the FBD of the point B, and here again two unknowns. After using Lamis theorem, we got the value of TBC and TBD. Here we have seen how to apply the Lamis theorem for the concurrent force system and the three forces acting at the point. Okay, so this is the formula for the Lamis theorem. I hope the idea about how to solve the problem of equilibrium of concurrent force system and the idea about application of Lamis theorem, okay, in the equilibrium of concurrent force system is clear to you. So we'll take a next question.